Assalamualaikum and good day everyone. My name is Nur Shifa binti Hassan. Today I will presenting the introduction of the chi-square test. The chi-square test represented by the symbol chi-square is a statistical method used to analyze categorical data. Categorical data refer to data that can be grouped into different categories such as gender, education level, or customer preference. This test was developed by Carlson in 1900 and has become one of the more widely used statistical tests in research and data analysis. The main purpose of the chi-square test is to determine whether there is a significant relationship between two categorical variables. In other words, it helps research identify whether two variables are related or independent of each other. Research use the chi-square test to compare observed data with expected data. By making this comparison, research can draw valid conclusions and make informed decisions based on statistical evidence. The chi-square test is commonly applied in various fields such as business, education, healthcare, and social science. For example, business may use it to study customer preference, while healthcare research may use it to analyze relationship between health condition and demographic factors. The chi-square test is important because it helps identify pattern and relationship in data. It also supports evidence-based discussion making and provide reliable results for research and statistical analysis. Next, I will explain the objective of the presentation. The first objective is to explain the concept and identification of the chi-square test. The second objective is to understand the purpose and importance of the chi-square test in statistics. The third objective is to demonstrate how the chi-square test is used in analyzing categorical data. The fourth objective is to discuss the application of the chi-square test in business, education, and healthcare. Finally, the fifth objective is to interpret the result obtained from the chi-square analysis. These are for the instruction section. Thank you.
Assalamualaikum, my name is Nur Shifa. Next, I will explain the theory of the chi-square test. So, the chi-square test is a statistical test used to determine whether there is a significant relationship or difference between categorical variables. So, it works by comparing the observed frequency, which is the actual data collected, with the expected frequency, which is the data we would expect if there was no relationship between the variable. So, for example, in this slide, we want to know whether gender influence brand preference. So, the chi-square test help us determine whether the differences we observe are due to change or if there is a real association between the variable. So next, there are two main type of chi-square test. So the first one is a chi-square test of independence. So this test is used to determine whether two categorical variables are related or associated with each other. So for example, we can examine whether gender is related to brand preference. If the test result is significant, it means there is a relationship between the two variables. So the second type is the chi-square goodness of fit test. So this test is used to determine whether the observed data match an expected distribution. So for example, if we expect customer to choose 4 brands equally, the goodness of fit test can determine whether the actual preference different significantly from the expectation. So in summary, the test of independence examines the relationship between two variables, while the goodness of fit test compare observed data with expected data. Now, let's look at the formula and assumption of the chi-square test. So the chi-square formula compare the observed frequency with the expected frequency and calculate the overall difference between them. So O represent the observed frequency and E represent the expected frequency. So the large the larger the chi-square value, the greater the difference between observed and expected frequency. So before using the chi-square test, several assumptions must be met. So the first one, the data must be categorical, such as gender, marital status, or product choice. Second, observation must be independent, meaning each respondent belong to only one category. Third, the data should be recorded as frequency or count, not percentage or average. So the last one is the expected frequency in each cell should generally be at least 5. So if the assumption are satisfied, the chi-square test can provide reliable and valid result. So to conclude, the chi-square test is a useful statistical method for analyze categorical data, identify relationship between variable, and compare observed result with expected outcome.
Good day everyone. For my part, I will explain the methodology and conclusion of the chi-square goodness of fit test. For the research scenario, a beverage company claims that customers equally prefer 6 different flavors of its beverage. To test this claim, a survey involving 120 customers was conducted. The observed frequencies for each flavor are shown in the table. The purpose of this test is to determine whether the observed customer preferences are consistent with the company's claim that all 6 flavors are equally preferred. Next, we formulate the hypothesis. The null hypothesis states that the proportions of customer preference for all 6 flavors are equal. The alternative hypothesis states that at least one flavor preference proportion is different. The significant level used for this test is 0.05 or 5%. Next, we calculate the expected frequency. The total number of customers is 120 and there are 6 flavors. Therefore, 120 divided by 6 equal to 20. This means that if the company's claim is true, each flavor is expected to be selected by 20 customers. Next, we apply the chi-square formula. The formula is the summation of observed frequency minus expected frequency power of 2 divided by expected frequency. This formula measures the difference between the observed frequencies and the expected frequencies. Now, let's look at the calculation table. For flavor A, the observed frequency is 15, while the expected frequency is 20. The difference is -5. After squaring the difference and dividing by the expected frequency, we obtain 1.25. The same calculation is repeated for flavors B, C, D, E, and F. After calculating all 6 flavors, the values in the last column are added together. For the test statistic, the calculation is 1.25 plus 0.20 plus 0.20 plus 0.00 plus 1.25 plus 0.00. Therefore, the chi-square calculated value is 2.90. Next, we calculate the degrees of freedom using the formula degrees of freedom equal k minus 1, where k is the number of categories. Since there are 6 flavors, degrees of freedom equal to 6 minus 1 equal to 5. Using the chi-square distribution table at a 5% significant level and 5 degrees of freedom, the critical value is 11.07. At this stage, we have obtained all the values required for the hypothesis test. Chi-square calculated value equal to 2.90, degrees of freedom equal to 5, chi-square critical value equal to 11.07. These values will be used in the next session to determine whether the null hypothesis should be rejected or not. I will now pass the presentation to my group member who will explain the interpretation of the result, the decision, and the conclusion. Thank you.
Hi, my name is Nor Farha, so I will continue our presentation.
Now I will explain the interpretation of our result. Based on the chi-square goodness of fit test, the calculated chi-square value is 2.19, while the critical value at the 5% significant level is 11.07. Since the calculated value is lower than critical value, the result is not statistically significant. This means the difference between observable frequencies and the expected frequencies are relatively small. Although some flavor receive slightly higher or lower responses than another, these differences are not large enough to indicate a clear preference for any particular flavor. Therefore, we can conclude that the customer preferences are relatively balanced across all 6 drink flavors. Next, we move on the hypothesis decisions. The null hypothesis H0 states the customer equally prefer all 6 drink flavors. On the other hand, the alternative hypothesis H1 states the customer preferences are not equally distributed among the flavors. Based on our analysis, we fail to reject null hypothesis because the calculated chi-square value 2.19 is smaller than a critical value of 11.07. This indicates that there is insufficient statistical evidence to suggest that customer prefers one flavor significantly more than other. As a result, the survey data support the company claim that customer preferences are equally among 16 flavors. Their finding can be applied in real-life business situation, especially in the marketing, production planning, and customer analysis. Since customer preferences appear to be evenly distributed among 6 flavors, the company can continue producing all 6 flavors without making major change to its product range. This helps the company maintain a balanced product portfolio and meet the needs of different customers. The result can also support management in making better decisions regarding inventory planning, product distribution, and promotional activities. Rather than focusing heavily on the one particular flavor, the company can allocate the resource more efficiently and across all flavors. As a recommendation, the company could conduct future survey involving large number of customers and perhaps include a customer from different locations of each group. This will provide more comprehensive information and help determine whether customer preference remain consistent over time. In conclusions, our presentation has explained the chi-square test, including its concept, type, formula, assumption, and practical applications. Using the chi-square goodness of fit test, we analyze whether customer equally prefers 6 drink flavor. The calculated chi-square value has 2.19, which was lower than the critical value of 11.07. Therefore, we failed to reject the null hypothesis. This indicates that there is no significant difference in the customer preference among the 6 flavors, and the company claim is supported by data. Overall, the chi-square is useful statistic tool and that helps researcher and business analysis categorical data and make information decision based on evidence. That's all from our group. Thank you for your attention.